Thank you, Victor, and thank you, Amatya, for the presentation. My name is Yaron, and I'll be talking about innovations in mapping and photogrammetry at the Survey of Israel. Now, my presentation will focus on 4 major developments that we are working on these days. The first one is I will talk about regulations. And regulations have to ensure that we have high quality mapping in the nation, but on the same thing, we want to ensure that developments in technology can flourish. I will talk about mapping procedures that we've just introduced, online tools, and I will continue with what Amatya said about automatic mapping, and I'll show you some of the tools that we are currently using in the Survey of Israel. Finally, I will talk about data sharing and how we try to encourage a data sharing ecosystem in the country. So first I will talk about why, and we know that geospatial data drives modern technologies in all the fields, in environmental protection, demographic and social services, public safety, finance, infrastructure. All these fields require good and high quality geospatial technology and data. And this is just an animation that shows how the world is gray without geospatial technologies, but when we use GIS and all these analytical tools, we can have modern infrastructure and map all these 3D utility lines. We can have 4D land use, namely we can use the underground, but we can also have dual purposes for each structure, like a school can be a school in the morning, but community center in the evening. We can have autonomous transportation, and that's a field that's becoming very important, and it needs high definition mapping. And smart cities, that's another buzzword, another growing field that we need to serve as a national mapping agency. Now we know that technology is developing in exponential rate, and that is a graph from Thomas Friedman. Thank you for being late. This graph shows how the technology is growing, but we as humans need to adapt. We are not as fast as the technology, and specifically with government, it's very hard for us to keep up with the technology. We need to somehow bridge this gap and be able to adapt faster and use more technologies smarter. So I will talk also about why we need high quality mapping, and I call it high definition mapping for modern infrastructure. That's for efficient land use, transportation, and smart cities. So we need accurate data, multi-dimensional, rich with attributes, and with high resolution. So I will start with the first theme about regulation, what we are doing in the nation to regulate the field. And we've just published last year the new Survey of Israel regulation. Now these regulations basically set standards for all the mapping professions and professionals in Israel. Every licensed surveyor and mapping professionals have to work according to these standards. And they include the basic outlines of accuracies, resolution, and specification for all the mapping procedures. This is somehow the fonts are not good, but let's see. Yeah, well, I have a problem with the fonts. I'm not sure what to do, but I'll skip this table, but it basically tells you at every single map scale what should be the required accuracy in root mean squared error and circular error probable. That's for the elevations. Again, I'm not going to go into the details, but if you want, we have published a specific article on the mapping standards in Israel. Now, here you can see the numbers, and for every accuracy level we require a special maximum pixel size in centimeters. For example, accuracy level 5, that will be equivalent to 1/2000 map scale, and for that we require 7.5 centimeter resolution. Now, not only that, we also set the minimum amount of details for each map scale. For example, if you want to have 1 to 1250 map scale, we need to have at least objects that are 36 times 10 centimeters large. This means every object that is larger than that will have to be mapped. Now, just to show you, we've seen resolutions. Today is in Israel, the national orthophotography is in 12.5 centimeters. We currently map the whole country every year at this resolution. In the borders, we use satellite images, therefore we have only 0.5 meter resolution. That's from, we use Pleiades and some other satellite resources. Now, of course, if we require this resolution and that amount of detail, we need to certify cameras and digital sensors. And we have a procedure by which we make sure that the sensor have right, what we call interoperability quality, and you can indeed map all these objects in this resolution. So you can see here one of the cameras that we have tested and made sure that you can identify all these objects. You can identify manholes, brick tiles, and so on. So we have a set of procedures, a 5-step process to check every aerial camera. First, of course, the mapping firm has to apply and request system certification. We look at the parameters of the camera and the specification. Then we have a field test, and we check it. We check the aerial photograph, make sure that it has the amount of detail, resolution, and accuracy that we require. This is being done by a certification body, a company that we approved to do the process. They submit their recommendation, and then we rank the camera according to its ability, according to its accuracy that you can achieve with that. So that's something that we did last year. We've published the regulations. This year we are also working on setting procedures. The procedures include specific standards for the actual content of the map and the layers, the format. We basically use DXF or AutoCAD format, and we have layers, like for example, layer 2500 is the layer for roads, layer 2000 will be buildings and so on. And then we also have a national standard for the cartography. This would be a building permit map. So every surveyor which submit a building permit map has the same cartography, the same layer setting, and so on. And that's published, and surveyors have to work according to this standard. Now, when we have the standard, we have a common language, and we've developed a tool that surveyors can download the data and they could submit their data. So in the beginning, we were using Web 1.0 technologies. Surveyors or experts would log in and get their data, download data from the national database and from other governmental databases. Now today we have a tool that they can actually submit their maps, and the tool creates, it has automatic quality control procedures, and then their data is uploaded to the national database. Today we still have a human operator that makes sure that the data is of high quality, but in the future I see a procedure that each surveyor can update the national database with the map and with using the standards. Now, so we've actually divided the field, our surveying field, to governmental data. We have a lot of national companies, power companies and so on that collect data. Local authorities and cities collect data, and land surveyor. The idea is that all this data gets into our national database, And when it's on a local level, they can download it because it's unclassified. When it's on a national level, it's secured, so only governmental agencies or ones that have the classification can download or get the whole entire database. That's what I call the lossless ecosystem of data sharing. So all the entities share the data, they can download and upload, and we don't lose important data. Now this is how the tool looks like. The surveyor basically uploads this project, CAD files, and there's a quality control tool that you can see how well your map is, if it's within standards, if there are warnings, errors, and so on. At the end, the tool presents the map, and it's uploaded to the national database. Let's talk about automatic mapping and Amatya, and even on that we have an article. And every one of these topics I have an article that actually explains more about the topic. Amatya mentioned automatic mapping, and of course that's a very big issue in Israel because we need to be able to very quickly update our national maps. In fact, the goal is for us to be able to update the map every year, at least the building layer. And we would like to have a high productivity rate and to have at least 1,600 square kilometers each day of automatic mapping. We mostly use open source software, but we also use some commercial software. And that's the procedure, the methodology that we use for change detection and updating our building layer. And I'm not going to go into the details. It was published. We have two procedures. One is the classification. We're using the elevation model at a resolution of 0.5 meter per point. We use morphological operations, and then we fuse it with the classification, with the segmentation. So there's a classification process, segmentation. At the end, we update our national database, and we also produce change map. And again, here is the procedure and how it looks on the aerial photograph. We have the input is orthophotography at 12.5 centimeters. In some areas at 25 centimeters, and at the borders we have 0.5 meter. And then we run the classification, and then segmentation, and improving the process with height correction. At the end, we get a map that says these are existing buildings, new buildings, and buildings that were demolished. Now we have the same process to update our land cover layer. And basically, again, we want a very quick process. Here we don't need the process to be performed on a yearly basis, but we do need to integrate it with a lot of data sets from other ministries, like from the agriculture ministry. We need to get the type of actual field, if it's wheat, if it's potato, whatever, wine, and so on. And we also get information from the forest agency. Now, even in the previous automatic mapping, we are right now looking at 85% accuracy level, which is comparable to a beginner operator. We still need to improve, and we are hoping to get more than 88, 90% like an expert operator. So that's the operation, that's the procedure with automatic land cover updating. We use eCognition and AirDust, but a lot of open source modules from OS, Geo, multi-resolution segmentations. We use training data, very similar to what Amatya was saying, SVM classification. And this is the procedure: segmentation, training data, classification. We combine them statistically, and basically at the end we also do some automatic generalization to get a high quality land cover map. Again, the same procedure. That's in Gush Dan area. the airport, Ben Gurion Airport, before and after. And that's, again, the whole procedure. And we are right now implementing it over the whole country. Again, we are looking currently at accuracy higher than 83%, but we would like to improve that using new methodologies. Maybe we will learn here about some more tools. Let's talk about data sharing, and our goal is to create an ecosystem of data sharing among all the surveyors and the people who collect data. And right now, and that's a cartoon, and right now it's very hard to convince other people to share data as power, and people are not willing to share data, even within the government. But we're working on it. And we see us as going to become a smart nation where data is seamlessly flowing between government and citizens. And efficient processes are being used based on intelligence analysis of the data. We've developed the online Geo-spatial portal, and that's a tool that is available online, govmap.gov.il, and it has currently about 2.8 million users every month. It has information from all the governmental ministries, 240 layers. We have the weather forecast, environmental protection data. It's now available on mobile. And we also have what we call a personal zone, where each citizen can use GIS tools, upload data. A lot of cities are uploading their own data. We have currently 5,000 layers created by cities and citizens. To conclude, basically, if we have good data, good analysis tools, and sharing culture, with not big investment, with small investment, we can have a huge impact on the services that the government can provide to its citizens. And mapping agencies like the Survey of Israel are taking lead in these activities. And that's basically my presentation. If you have any questions, thank you.
Thank you very much, Yaron. And вопросы, пожалуйста, коллеги. Наверное, вот вопросы от Роскартографии, кажется. Бдительная просьба, когда задавать вопрос, пожалуйста, просите микрофон, чтобы работали переводчики. Еще раз вопросы. Ну, задай какой-нибудь основной. Микрофон.
Так. Во-первых, хотел поблагодарить великолепный
И представляйте,
доклад.
пожалуйста.
Роскартография, Серебряков Сергей Владимирович. Хотел задать вопрос, поскольку двигателем все-таки любого бизнеса являются это доходы. Хотел понять, при производстве вот этих пространственных данных, у кого остаются права, и как пространственная вот эта информация, произведенная в государственной структуре, как она в бизнесе участвует. Где двигатель, где доходы? Спасибо.
Okay, well, that's a good question. Indeed, the Survey of Israel is a public entity. We are owned by the government, and we don't need to make profit. Now, we hope that we will be able to provide our data as open data. Right now, we have some limits on that, some of them from the Treasury Ministry. And so far, we have not released, for example, our building layer or our road layers. We did recently made it openly available, the cadastral layer, and some other layers like point of interest, like hydrology layer, rivers, and so on. We are making now as open data. Now, about this procedure of surveyors uploading their data and so forth, these maps are basically maps that are produced to get permits. So they are required by regulation. And so as part of our control process, we update our national database. and we present it for the whole public, and you can actually have web services to use the data, but so far it's not open, and that's something that we are working in to really open all our data to the citizens. It's not going to be something that you will be able to use for building permit, but it's because the accuracy of the national databases should be like 1 or 2 meters root mean squared also, but it's still going to be good enough for some applications. Did I answer your question?
Еще вопросы, коллеги?
Ну, вот у меня есть вопрос, там были интересные слайды, как раз после того слайда, где была проблема со шрифтами, о нескольких уровнях точностей. Но вопрос такой, вот можете приблизительно сказать соотношение между разрешением при съемке, между GSD, Ground Sample Distance, и выходной точностью?
Okay, yeah, I wish I could show you these slides, but I will send you these slides, but I will actually explain. So what you see here, level number 3, that is the level that is of 1 to 250, and the accuracy for that is about 6 centimeters root mean squared error. Okay, so roughly about, so for that it's about 6 centimeters. For level 4, I'm talking about 13 centimeters. So roughly it's a little bit more than 2, okay? And for level 5, which is 1 to 1,000, we are talking about 25 centimeters accuracy. And for level 6, that will be about 3 times, so 30 centimeters. Now, these were, we've tested it empirically, okay? So I don't think there is a formula connecting, but I think this is a pretty good standards, and we've got some good positive feedback from the surveying community on the fact that these resolutions indeed provide better maps for the accuracy. So again, that would be a 1 to 1,000, which is 25 centimeters root mean squared error. What you see here, number 5, level 5. And level 8 would be the equivalent of 1 to 5,000, okay, which is 1.25 meters. So level 8 is actually with resolution of 25 centimeters, you reach about 4 meters accuracy. So it's not linear graph, it's not, but it's empirical, okay?
Вопрос, коллеги, еще. Maybe I will ask you also one question, because actually a lot of questions, but unfortunately we have no time. But the question is that do you have a formal regulation or formal rules in upgrading of spatial information? I mean, for example, every year you should make aerial survey to upgrade and so on and so on. It's maybe the first question, and the second question, what data, satellite or airborne, are mostly used?
Okay, so basically to update our national orthophotograph, we use aerial photography from digital cameras, and every year it's a year and a half practically, we want to get a 12.5 centimeters orthophotograph of the whole country. Now in some areas we have problems like illegal building constructions. In these areas we do have requirements to actually update the orthophotograph every month or 2. So to be able to identify illegal buildings. And that's mostly in the south of Israel. So we are now looking at options of updating, very quickly updating the national orthophotograph to be able to identify these illegal buildings and try and give it to the police to act on these illegal buildings. So that's as far as the national orthophotograph, 12.5 centimeters every year and a half. As far as the updating of the building layers, again, we are talking about every year and a half, something like that. Very concurrently to the orthophotograph, we are updating our building layers. As far as the road layer, we do contract the services of a company called Here, and they have cars driving, and so every quarter of the year, every 3 months, we get an update of the new roads. Lane cover, we hope to update every couple of years, 4 or 5 years, that's our goal. And hydrography, again, we work with the local authorities that they would provide us data and we can update if there are changes to the drainage and so on. So every layer gets a special treatment today. It's not like we have national maps. So on every layer we have the experts that use the technology specifically designed to update the layer. But essentially the whole map should be updated, the whole map hydrography and build. So 3 years, that's what we hope to, and that's what we have right now. That's the updating process, the average.
Yaron, thank you very much. Actually, a lot of questions. I do hope you will be with us here and we will
Yes,
discuss.
I will.
Thank you again.
Thank you very much.